10, Miss ID here one more time. This is the last lesson on this small unit of exponential functions, and today we're going to look at the exponential graph. So you should have seen it at some point earlier in the year when we looked at graphs and functions. An exponential function is where x is in the numerator. So here is the very general y equals a to the x, where a can be any number we like. You should know this general shape, that it looks like this. It makes sense because if you replace the a with 2 or 3 or 4, any number you like, as soon as you start raising that to a positive power, those numbers are going to get big quite quickly. So that's why it's getting very steep in the positive x direction here. Also, you should know then, now that we've done some work on exponential functions, that when you raise it to a negative power, you actually write it as a fraction. So this is why here in the negative x direction, the graph is actually the y values are getting smaller and smaller. Now here it looks on my diagram like it actually touches the x-axis, but it doesn't. It just gets so close, the number gets so small that you have to keep zooming in to see that there actually is a gap there. This brings me to the fact that this exponential function has what we call an asymptote. An asymptote, remember, is a line that the graph gets really close to but never actually touches. So for your parent function y equals a to the x, the asymptote is y equals 0, the x-axis. Also, your parent function, when it's just y equals a to the x, where a is any number, it will pass through the point 0, 1 on the y-axis. Now this will change as soon as you add different parameters to your function, so this is not always the case. As soon as you start moving this graph up and down, sideways, as soon as you do some sort of stretch, that y-intercept will change. So that's your basic parent function. That you should already know. And what we're going to do is investigate this parent function a little bit more closely and apply some of our transformation knowledge to this function. So you should have this blank on your page. So what I would like you to do is I'd like you in a moment to pause this and say, if y equals f of x, so y equals some function, doesn't have to be an exponential function in this case, what happens to the graph if you add a number? Let's call that number a. So just write a sentence there. What happens to the graph? How does the graph change if you have f of x, the function, plus a number? And then similarly, if you have the function minus a number, etc. So if you add a number to the x, subtract a number from the x. If you multiply the function by a negative, if you multiply the x by a negative, if you multiply the function by some number, or if you multiply the x by some number. So pause this video right now and see if you can write down as many of those as possible to see what happens. Okay, pause now. Okay, so hopefully you paused that. Welcome back. So here are the types of things that you should have written down. They don't have to be exactly the same words, but the idea of the transformation should be the same. So if we add a, the whole function moves up a units. Now this is important for the exponential function because the asymptote is part of that function. So if the whole graph moves up, the asymptote must also move up. Here, for the minus a, the function moves down. That means also the asymptote will move down. Anything inside the bracket with the x is a horizontal transformation. And here, remember, it always works the opposite to what you think it should. So if it's x plus a in the brackets, then it will actually move to the left a units. And if it's x minus a, it moves to the right. Then if we multiply the function by a negative, it reflects it in the x-axis, because what it's basically doing is it's making all of your y values negative now. And then similarly, the function that has the negative x, it's reflected in the y-axis because it's taking all of your x values and making those negative, but the y's stay the same. If you multiply your function by a, then it's a vertical stretch by a factor of a. Oops. And if it's inside the bracket, it's a horizontal stretch. Oops, I just realized there's a typo there. A horizontal stretch But that's by a factor of 1 over a. If I just pull up Desmos here, we can see here is then our most general parent function for an exponential. If I start with the b, I can see as soon as I start moving that b to a number, I had it at 2 to start with, otherwise it becomes a straight line. I started there, and if I make that a number bigger than 2, I can see my graph gets very steep very quickly, which makes sense because you're raising then a big number to big power. If I change it to a negative, I'm going to leave that for the minute because that's not so important right now. Let's do the easy one. If we do the plus d, this is our vertical shift. I can see that it moves up. Now, unfortunately, what happens is Desmos doesn't show the asymptote there. The x-axis is the asymptote. If I add 3, for example, what happens is everything moves up 3. So remember, the asymptote is initially y equals 0, so that would move up, and the line y equals 3 would now be my asymptote. When you draw these or sketch these functions, you must draw that in, and I'll show you what I mean later. I'll put that back to where it was. Let's look at the c in the brackets. So this is your horizontal movement. If it's a positive number, it's not so obvious here what's happening, but it actually moves in the other direction to what you think. So this is moving left. And if I make it a negative number, remember that's saying x plus that number, so x plus 1, for example. And you can see here, let's just change that to -1 again. You can see here now my y-intercept is actually at 2, because what happens is when it was the point 0, 1, that's been moved across to over here, and I can see it's there. And so that was 0, 1. Normally, I would have 2 to the power of 1 is 2, but that gets moved across to the left, etc. So the graph is it looks like it's changing the steepness, but it's not. It's actually moving. Okay, I'll change that back to 0. And the last one is the a, so this is where you're multiplying your function. If I keep it positive to start with, I can see this time it is changing the steepness because I'm making it an even bigger number. So that becomes positive. The other thing I want to do is if I make this negative one, we'll see the change. Oops, let's make it negative so it's a nice easy. I can see it's flipped over the x-axis. If I move that back, and let's put that back to 1, if I change this to, maybe I need to change it here. If I change that to a negative, I can see then clearly there that it's just changed. It's flipped it over the y-axis here. So that's just confirmed everything that we just said before. These you should know already. We've done transformations many times now, so you should know these. That's just a refresher. Okay, let's put it into practice. We need to sketch these functions. All right, let's get a pen. So, think about what your general graph looks like. 2 to the power of x would just look something like this. If I draw that on there. Oops, it's very hard to draw. And then our y-intercept would be 1. This would go on to forever, and that would be 2 to the power of x. And the x-axis is the asymptote. Now, it's x plus 1. You should always do the things with the x first. So plus 1 means everything's going to get shifted to the left. This means horizontally to the left. The negative means the whole function's going to get flipped, and it's going to get flipped about the x-axis. Let's do this shift first. So let's do it in stages. I'm going to move it across 1. So that means this point would now move over to there. And instead of being at 0, 1, that point would be at -1 because my x value is changing. My y value is not. That's staying the same. And that's all that would change. So it would have the same shape. So it's still going to have that shape, but everything's going to go across 1. And it still means that it will have this x-axis as an asymptote. So that would be 2 to the power of x plus 1. And then if we flip it, so this gets flipped upside down. Remember, I haven't had any vertical movement, so my asymptote stays the same. So this point minus 1, 1 gets flipped upside down. Let's say that's there. It's just a sketch. So that would be the point minus 1, minus 1. My x-axis is still an asymptote. And I might just move this down. Then it's just going to go down like this. And that's going to approach the x-axis. So what would actually happen, sorry if I just finish this first, minus 2 to the x plus 1. If I wanted to know where my intercept was, I can go back to here and find out, okay, it's got to be moved across 1 first. So that would have been at 1, it would have been the point 1, 2. Because I would just substitute 1 into my function. So 2 to the power of 1 is 2. So then for our red function here, our intercept would have been at the point. So this has got to be moved across. So it's now 0, 2. And then that gets flipped upside down. So now I get it down here. That would be the point 0, negative 2. Remember, it's a sketch. You should show some numbers. This is important. But this is good enough. That's clear. That would be the point minus 1, minus 1. You don't have to plot loads of points. Show the asymptote and maybe the intercept if you can find that easily. Show that point, and if you can choose another point. Good. Let's try one other one. 3 to the power of minus x minus 2. Okay, let's think about this bit first. Always do the bit with the x to start with. Now all this does is it just changes the steepness, but if it's a sketch you don't need to worry about that so much. So we think about what does it normally look like. Let's think about 3 to the power of x is going to look like something like this. Y equals 3 to the power of x. Then I need to think about what does my graph, let's quickly state what that would be. That would be the point 0, 1. Now let's think about this transformation. This minus x, it is a horizontal flip. So it flips in the y-axis. So the y-axis is like our mirror. So it's now just going to be going the other way. Just like this. At this point, the x-axis is still the asymptote. So this is y equals 3 to the minus x. Same y-intercept. Nothing happening there. Nothing changing there. This goes on forever. And then the minus 2. What does the minus 2 do? Well, it's outside the function. So it moves the whole function down. I might just move my screen up. So that means because we're having a vertical movement, that our asymptote changes. So now our asymptote changes from, remember it was y equals 0, it now changes because we have to move down 2, and we draw an asymptote as a broken line. It's going to be the line y equals minus 2. And you should clearly show that on your sketch. Try and make that maybe a little bit more horizontal than mine is there. And we move the whole graph down 2. So if I take my intercept, that's normally the easiest one to move first. So I go down 1, that would get me to the origin, go down another one. So it's going to be at the point 0, minus 1. The shape has not changed. This is an asymptote, remember, so your graph should get closer to this line. So make sure when you sketch it, it looks like that's happening. You can put an arrow on the end. And then it's going to go up. Oops. Something like that. So that is y equals 3 to the negative x plus 2. This intercept might be a little bit hard to find, so that's okay. As long as you show with an exponential, the y-intercept and the asymptote are the two major things, and of course get the shape right in terms of that it's that kind of getting smaller at one end and bigger at the other end, regardless of which way it goes. All right, time for you to have a practice. Good luck. Bye.